Second module, system of limits, fits, tolerance and gauging, definitions, tolerance, tolerance analysis, addition and subtraction of tolerances, interchangeability and selective assembly, class and grade of tolerance, fits, types of fits, fit and tolerance, hole based system and shaft based system, Taylor's principle, types of limit gauges. Introduction. It is a known fact that no two things can be similar in nature. Every process is a combination of three elements: man, machine, and material. A change in any one of these will constitute a change in the process. All these three elements are subjected to inherent and characteristic variations. Hence, it is impossible to produce a part to an exact size, and some allowance known as tolerance has to be allowed. This tolerance allowed depends on the functional requirements. In engineering practice, any component manufactured is required to fit or match with some other component. For example, if a shaft has to rotate in a bush, there must be enough clearance between the shaft and bush hole to allow the lubricating film to be maintained. If the clearance is too small, excessive force would be required for rotating the shaft. On the other hand, if the clearance is too wide, there would be vibrations and rapid wear. Tolerance. Consider the dimensioning shown in the figure. A shaft having a diameter of 40 plus or minus 0.05 mm. When making the part, we try to achieve a diameter of 40 mm, that is basic or nominal diameter. The shaft will be satisfactory if its diameter lies between 40 plus 0.05, 40.05 mm and 40 minus 0.05, that is 39.95 mm. The dimension 40.05 mm is called the upper limit, and the dimension 39.95 mm is called the lower limit. The difference between the upper and lower limits is called the tolerance. Tolerance in the above example is 40.05 minus 39.95 is equal to 0.10 mm. It is impossible to make anything to an exact size, therefore it is essential to allow a definite tolerance or permissible variation on every specified dimension due to the inevitability of human beings and machines. It is defined as the magnitude of permissible variation of a dimension or other measured or control criterion from the specified value. Why tolerance need to be specified? Variations in properties of the material being machined introduce errors. The production machines themselves may have some inherent inaccuracies. It is impossible for an operator to make perfect settings. While setting up the tools and workpiece on the machine, some errors are likely to creep in.